guys, welcome to our secret hideout. You may have heard of us, you may not have heard of us. We are a group of awesomeness. My name is Megan, this is Debbie, and this is Fung. We hunt stuff.
We explain the unexplained.
And investigate the unusual.
I am the technical person.
I am the legendary news reporter.
And I am the video camera person. I record everything.
Nothing interesting has happened in a while, but we're on a brink of a new discovery. Just know it.
Yeah, I mean, nothing exciting's happened in a while, so something should be coming up pretty soon.
And when it does happen, I will record it. And then we'll make a movie.
We'll keep you informed.
Hey guys, it's Megan here. I'm hanging out with Debbie in our lair.
Secret lair.
She's intently working on a Rubik's Cube, but failing miserably.
You're right.
Breaking news. I just talked with an officer, and from my intelligence agency, there's been news of a monster.
Monster, man, that's just what we do.
We have to find it!
Okay, so what can you tell me about it?
Well, we reported mysterious activity in an abandoned building nearby.
Abandoned building. Okay, is it? I mean, how far away is it? Can we go there?
Actually, it's pretty close. It's kind of scary. About 7.8 miles.
Maybe we should start talking to some people before we go in there. I mean, we don't know what to expect, right? Yeah, so we should probably go interview some people and see what we can find out about this monster. Does it have a name?
Actually, they don't know what kind of monster it is, but they just call it Pie.
Pie. Alright, let's get our gear. Let's go.
You have just witnessed the start of the Great Pie Project. We're going to find the monster.
Finally, after all my hard work, now is the time. It's alive! I will call it Pie!
Welcome to the first day of the Great Pie Project. Fung, Debbie, and I are going to find people to interview about the pie monster.
Yeah, Fung, are you ready to go? Fung?
Fung!
Fung?
Fung!
Oh my god! Oh my god!
There's
nobody here!
Fung!
Fung! Must have been the pie monster. Our first interview is with Professor Ikiswakistan, and he is actually the leading expert on pie. Hello, Professor.
Very nice to meet you.
How are you doing today?
Good, how are you?
I was wondering if, since I know that your life work is dedicated to finding pie, I was wondering if you could help us out in any way, if you could show us what you know.
One method for calculating a numerical approximation of pi would be using a unit circle given by the equation x squared plus y squared equals 1. By definition, we know that the area of a circle is pi r squared. Since the radius of a unit circle is 1, the area is going to be equal to pi. Solving the original equation for y, you get y equals the square root of 1 minus x squared. You're then going to take the area of half a circle, since that equation only gives you the area of the top half of the circle. So area of a half a circle then would be pi over 2. You could then solve the integral. Pi over 2 equals the integral from -1 to 1 of the square root of 1 minus x squared dx. And of course, integrating that is just a ton of fun.
So, to solve such an integral where you have the square root of a constant minus x squared dx, you first use a technique known as inverse substitution, where you let x equal sine theta. And then start working through it from there. So that's going to give you square root of 1 minus sine squared theta, and then to substitute in for dx is going to have to be the derivative of sine theta, which is cosine theta, d theta.
And from there, we're going to have to actually take a look at the trigonometric relationship we developed. So, using triangle, for this angle theta, we have 1 of the radius of the circle back there. That's going to give us our hypotenuse on triangle. Sine side is going to be x, and then we're going to have square root of 1 minus x squared. So substituting back in that way, we're going to get, let's see, 1/2 inverse sine of x, which will translate back and give us a value for theta. The inverse sine of x will be equal to theta. And then our remaining part to take care of this 1/2 sine theta cosine theta. We're going to get x over 2 divided by the 1/2 sine aspect of it, and the cosine is going to come here, square root of 1 minus x squared. We substitute now back into that our bounds being -1 to 1, so we're then going to get that equals 1/2 inverse sine of 1 plus 1/2 square root of 1 minus 1 squared. That minus 1/2 inverse sine of -1 plus 1/2 square root of 1 minus -1 squared. That will then end up reducing down to 1/2 of the inverse sine of 1 minus the inverse sine of -1. Now we know from our definition of this integral at the beginning that we have the whole thing equal to pi over 2. So therefore our final solution would be canceling the 2's out here, and we have pi equals inverse sine of 1 minus the inverse sine of -1. Now anyone who wants to question that, take a graphing calculator, plug it into radian mode, and type that in, and you will get 3.14, etc., all the way up to the decimal places of pi.
Wow! Well, that's really impressive. Thank you for meeting with us, Doctor. All right, let's head out. All right, we're in the library now, and we're going to see if there's anybody here who can interview. I think we have a very interesting subject here. Excuse me.
So beautiful. The U substitution.
So do you mind if we ask you a few questions?
Go ahead. You're just interrupting calculus.
Oh, calculus. Well, first of all, have you heard anything about a recent disappearance? No? Okay. Well, since you're talking about calculus, maybe there's something that you can help us on. You see, we're trying to find pi.
Ah, yes. You know, I once wrote a book. By the way, my name is Steph N. Hockling.
Oh, nice to meet you.
I once wrote a book. It is called A Brief History of Pi, or as they say in Spanish, ¿Dónde está el pi, Pedro? Yes. Well, as you know, the ancient Babylonians calculated the area of a circle by using pi equals 3, and one Babylonian tablet from 1900 BC indicates a value of 3.125. The Egyptians also used pi in their Rhind papyrus, which is 1650 BC, and they used 3.1605. The first calculation of pi was done by Archimedes of Syracuse.
Oh, Syracuse.
Yes, and he found pi to be 22/7, which is the value we use today.
Ooh.
And the Chinese astronomer Zhu Chongzi also calculated the ratio of the circumference of a circle to its diameter. And the pi can also be found in the Bible when it says, he made a molten sea 10 cubits from the one brim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it about. The Bible used pi equals 3. Anyway, the Mayans used pi.
And the Mayans.
Yes, they used pi. And different scientists in the 1700s used pi. I can go on for days and days and days.
Yeah, I'm sure you
But
could.
let me just tell you that the English mathematician William Jones in 1706 wrote pi equals 3.14159. The symbol was adapted by Euler in 1737 and it became the standard symbol for pi.
Wow. Well, thank you for talking to us about pi.
You're welcome, dearie.
And hopefully it'll help us locate pi.
Let them eat pie, I say. Let them eat pie.
Okay, thanks again. Bye.
Bye, thank you.